Okay, my name is Daniel Steff, and this is my Lab 1 lab report. Um, so, what is the purpose of this lab and physics? Well, we wanted to test to see if we could find constant velocity in this lab report. We wanted to see especially the differences between simulated data and data that we gathered ourselves, and see how that differs, and also just test to see constant velocity and the impacts it has. So the main physics principle that we used during this experiment was F equals ma, where that force equals mass times acceleration. Because acceleration is the change in velocity over time. If the force is zero, or if there's no force acting on an object, then its change in velocity must also equal zero. So that's an important principle, because it means that assuming there is no force acting on the object, and the object is moving at constant velocity, which is what we try to test for. So what happened? Well, what happened is that we found this cart and this track, and we pushed the cart on the track, and as soon as it left our hand, that meant that there was no force acting on the object, at least for the experiment's sake. So therefore, it should have been moving at constant velocity. We then took a video of this occurrence, and we showed that, or we took a video and found how fast the object was moving through the video, and we noticed how, or then we graphed this data, and we could see if the velocity was constant or not. So the system would have been the cart itself that was being acted on, and then the surrounding would be the air around it and the track and pretty much everything else in the room except for the cart. Some details about this is that we conducted this experiment. It went really well. Took a video of it. We had a meter stick in the video so that you could tell how fast the car was actually moving in meters per second as well. So some coding. We had to do a little bit of coding in this experiment, in this lab. And in this coding that updates the ball's velocity, or the object's velocity and position, we made sure to put our Fnet as 0, because there was no forces acting on the object after it had left our hand. And the ball position, or the object position update formula, we had our initial velocity as negative 1.9157, because we graphed our data, and that was the slope of that graph, which shows, or the slope of the position versus time graph, which would show about how fast it was moving. So what did we find? Well, funny you should ask. We found constant velocity. That's right, constant velocity. As you can see, this is our data taken from our coding simulation, and it shows that the velocity was constant, and that the position versus time graph was a linear line that was straight. Comparing this to our data of our simulation, it shows that that they're very similar. They're only opposite because one of them, we flipped our axes to account for it moving, and the other one we just said that negative position would equal going to the left, which is what the object did. But as you can see, they're both linear lines for the most part. The data that we took was a little bit not perfect, and part of the reason was that because of some potential errors, such as friction of the ball, or of the object on the cart, and the track that could be slowing it down slightly, and air resistance that also would be slowing down the cart slightly. I guess those are some forces that are on display with the cart, but not much we can do about that. Could have been a little bit of human error as well, just from recording it. Maybe we made some mistakes, or our software could have been a little not perfect, but overall it was very close to being good. But got to address the errors. Thanks for watching.